Hi, 5.2. Welcome. Two events are called disjoint if they have no outcomes in common. Another name for disjoint events is mutually exclusive events. If we find the probability of two disjoint sets, E and F, or two disjoint events, mutually exclusive events, then the probability of E or F is equal to the sum of the probabilities. The probability of E plus the probability of F. This is like the union in your math class, and that's the way disjoint events add. The complement event is like the complement of the set. So let S denote the sample space for the experiment, and E is an event within S. Then the complement of E, denoted by E, it looks like an exponent C, is all outcomes in the sample space that are not outcomes in the event E. Now, because E and E's complement are mutually exclusive, they are disjoint, there's nothing in the intersection, the probability of E or the complement of E, that's going to be the union, that's the entire sample space, is 1. Now, and we also know, since these are disjointed, it's the sum of the two. So what I can do is I can subtract the probability of E's complement from both sides, or actually I'm subtracting, I guess, the probability of E from both sides, and I get what is called the complement rule. If E represents any event, and E complement represents the complement of E, then the probability of the complement of E is equal to 1 minus the probability of E. Sometimes it's easier to calculate the complement than it is to calculate the probability of E. Here are 10 problems. You know what to do and when to do it. Let's see how you did. We just add the probabilities there, get 0.7. They have nothing in common, and so the probability is 0. There is no overlap. This is E and F. The probability of E complement is 1 minus the probability of E. That's the same for 18 as well. Here, what you have to do is you have to subtract the overlap, the probability of E and F. I may have put this a little bit in the wrong place, and sorry about that, but you'll see this soon, and so you'll understand that. This is the same thing also. You have to subtract off if there is an overlap. And here you are just adding the events. Here is a complement, and here is another complement. Here is another problem. You know what to do and when to do it. Let's see how you did. Well, the probability of 4 or more rooms, these are disjoint events because you have 4 or 5 or 6 or 7 or 8. So that's 4 or more. So you just add the probabilities and you get this. The probability of fewer than 8 is 1 minus the probability of 8 or more, and we already calculated the probability of 8 or more. And so what we can do, or excuse me, fewer than 8. Fewer than 8 is 1 minus this number, so we can do that and do the calculation again with the complement. From 4 to 6, we add those 3 and get this answer. And at least 2 means 1 minus the probability that there's 1. Now at least 2 means 2 or more, so this is it, but the complement is just 1. There was no place where there were 0 rooms. 2 problems with cards. You know what to do and when to do it. Let's see how you did. These are disjoint, a heart or a club, so you add them together. A heart or a club or a diamond, you add them together and get this answer. An ace or a heart, you have to subtract off the probability that they intersect. So what's the probability of the ace of hearts? It is 1 out of 52. And the probability of 2 or 3, you just add the 2 together and put it in lowest terms, and you get that. This is B. You add the 3 disjoint sets together, and here you have to subtract off the intersection. Here's a birthday problem. You know what to do and when to do it. Let's see how you do. Okay, not on November 8th is 364 out of 365. Not on the 1st is, you subtract off the 12 firsts, and that gives you this probability. Not on the 31st is 1 minus. The probability on the 31st, there are 7 months with 31 days, and so there are 7 days that start the month that fall on the 31st, and you subtract. And not in December is 1 minus the probability of being in December. There are 31 days in December, and that's how you do that calculation. Here's a survey about people who died from cancer and their smoking habits. You know what to do and when to do it. So you look at the table, and the probability that you died from cancer is 1,000. We added up these numbers here to get a little bit over 1,000 out of the total, and that's the grand total. So the probability that people died from cancer was a pretty small probability. The current cigar smokers, the probability of being a current cigar smoker was this total, and that is a row total. And actually it's I guess really it is a total of, let's see, current, those are across this row, divided by the grand total. Probability you died from cancer and are a current smoker. Died from cancer and are a current smoker is down here. So you get that over the grand total. And here we add the two together and subtract the intersection, and we get this number. Here's a problem dealing with the placebo effect in a medical experiment. You know what to do and when to do it. Let's see how you did. Okay, so you made I guess we had this table, and so what you know is that there are 100. We add this row that we're given the placebo out of the grand total of 250, so that's the probability of placebo. The probability the headache went away is you sum this total, it's 188 over 250, and of the 250 participants, 56 were given placebo and reported the headache went away. That's this 56 right here, and so this is going to be 56 out of 250. Here is a survey about social media, and it's showing a contingency table, and so it's how much do you use social media based on your age. You know what to do and when to do it. Let's see how you did. This is your answer for the first one. This is your answer for 2, or B, I guess. This is your answer for C. And your answer for D is down here. "5.3 is a place to be."